We can continue only when these terms, magnetic meridian, geographic meridian, are crystal clear. So once more I am presenting the three-dimensional view. This is this gray shaded wall, which is a vertical plane. Whenever I say vertical, look at the person. So for the person, that's a vertical wall like thing. Anything like a wall near you. The wall, the vertical wall, which is in the north magnetic, south magnetic direction. This is different from the north south direction that we normally use. That is geographic. This is the magnetic direction. This plane is called magnetic meridian. Earth's magnetic field will be only in this plane. It is not in the geographic plane. It's only in the magnetic plane. So this should be very clear. So whenever I say magnetic field of Earth, you should imagine that happens only here in this plane. It will be vertical, downward, upward, horizontal, all in this plane. Now see, there is this person standing on the ground, and there is magnetic north pole on his right side and magnetic south pole on his left side with respect to the person. Fine. Now as I said earlier, the magnetic field line can be vertically upward at that place, it can be vertically downward at that place, it can be inclined or it can be horizontal. So once more, if the magnetic field is vertically downward, if the magnetic field is vertically downward like this, which pole it is? He is standing on the north magnetic pole, which is near the north geographic pole. You can imagine Canada. So that is the north magnetic pole. Assume that the magnetic field line is vertically upward with respect to the person, parallel to his body, going from feet to head. Then this person is standing on the south magnetic pole. Standing on the south magnetic pole, think Australia. And if this field is inclined and out of the plane, inclined and out of this plane, you can see it is inclined with respect to the horizontal, then this is somewhere in the southern hemisphere. And if it is inclined and going in, be an Indian, this is in the northern hemisphere. In India, this is the case. In your place, the magnetic field is in the magnetic meridian, and that is inclined and going into the ground. Now imagine a person standing somewhere here. This person should be you, because when you get a question, you need to think in this angle. Okay, the person is standing and he is in the magnetic meridian. So the wall behind him, that is the magnetic meridian. Okay. Assume that the magnetic field at that place, is inclined like this. It is inclined with respect to a horizontal. So you can imagine a horizontal line which is parallel to the ground and a vertical line which is perpendicular to the ground. So the Earth's magnetic field, then the horizontal line and the vertical line. This is generally called as B. That is a total field of Earth. See, when I mark it inclined and out of the surface, then that must be in a southern hemisphere. But this is applicable, the theory is applicable for every place on Earth. Now this angle is called delta. This is called inclination angle. It's also called dip angle. How to define that one? The angle with the horizontal and Earth's magnetic field is called angle of inclination or dip. Okay. If you take a magnet, suppose you have a support here, and you, in a thread, if you suspend a bar magnet, suppose you suspend a bar magnet like this, then what will happen? The bar magnet will not stay horizontal, the bar magnet will stay like this. Like this. Okay. So the bar magnet will stay in the magnetic meridian, but that will be parallel to the magnetic field of that Earth. So here that will be like this, inclined. Okay. Now, since we are dealing with the Earth's magnetic field and that is a vector, we always resolve that into convenient forms. One component will be taken parallel to the ground and the other one will be taken perpendicular to the ground. So here we'll have one component in this direction and one component in this direction. This is called the horizontal component, which we normally write B cos delta, and this is the vertical component BV, which we normally write as B sin delta. So angle delta is here. So how to find delta if you are given the components? If you are given the components, delta can be calculated using the tangent law. Because we know if you divide BV by BH, you are getting tan delta. BV by BH is tan delta. So I'll write that here. BV equal to B sin delta. BH is equal to B cos delta. So if you divide BV by BH, you are going to get tan delta. This is called tangent law. Tangent law.